Greetings and welcome to, you guessed it, another installment of QuantSlob. This is 34 in our basic application series. This time around we're going to motor on with part 6 of our exciting summarizing data series. In this installment here we're going to focus on some ways to summarize two categorical attributes, more particularly how to convey their bi-variate distribution, bi to variate variable. One very important side effect of summarizing a bivariate distribution is that it can help reveal the nature of the relationship between the two attributes. But before we get too deep in this, let's visit our previous super futuristic QuantSlob challenge. So, how might we describe the shape of this distribution? The shape of the shaded area. It's a histogram. Well, I would start by saying that this is not something we can easily liken to something we might see in nature. Not really. I mean, it looks a little like Half Dome here in California. This photo of Half Dome, like most, was taken from the southwest, and I flipped the image so that the dome is on the left, and then I scrunched the width quite a bit. Maybe a little like the right side of a half pipe, but I think both of these are kind of a stretch. Let's try thinking a little more abstractly. How about like a cartoon mountain? A mountain that is really steep and lopsided. Lopsided or skewed. Skewed as in skewed out towards the left. Or even more abstractly yet, we could simply say that it is asymmetrical, meaning that it doesn't look like its mirror image. Okay, so as a fair heads up, there's a lot of moving parts in this video, so hold on to your hats, and if you're not wearing a hat, make sure to hold on to something. So let us return to our Major League pitch by pitch data. With total deliberation, we're going to recode our pitch type categorical attribute. So including the category not recorded, pitch type was not recorded, pitch type has a total of 16 categories. Now, by the way, we can call this attribute a 16-level factor. That's just another way of saying a categorical attribute with 16 categories. So from this, we're going to create a new attribute, a 2-level factor called pitch type off speed. It's two categories we're going to call heater and off speed. We're going to intentionally remove automatic balls and not recorded here. So here's our mapping. So check it out here. 4-seam fastball, cut fastball, 2-seam fastball, fastball, and sinker, sometimes called a sinking fastball. We're going to roll up into our new category heater. And the remainder are going to get rolled up into our new category off speed. Heater, for aficionados, you'll already know this, is like baseball slang for fastball. Now, we could simply label this new category simply fastball, but I think it is very bad practice to have the same label used more than once in the same data set. The label fastball, you can see here, is already taken in our original pitch type attribute. Okay, so let's take a look at the distribution of our new categorical attribute. Looking at a bar chart here. It looks like a fairly heavy preponderance of pitches in our data are heaters. About 3.8 million heaters compared to about 2.2 million off-speed pitches. Now, next thing, we're going to create another 2-level factor, and this time from our numerical attribute pitch start speed, or simply velocity. We're going to do this by splitting at the median value, 89.5 miles per hour. Pitches whose velocity is 89.5 miles per hour or less, we're going to categorize as low velocity. Those whose velocity is greater than 89.5 miles per hour, we're going to categorize as high velocity. So now let's take a look at the distribution of this new categorical attribute here. Again, a bar chart. Here are two categories we can see are almost equally popular, and this should not be a surprise. As we have learned, the median value splits our collection of numerical values in half. Okay, so now for the big payoff. I know how much all of you enjoy a two-way frequency table, so here we go. A two-way frequency table, also known as a contingency table, shows the bivariate distribution of our new high-low velocity categorical attribute and our new heater off speed pitch type categorical attribute. Frequency tables are, I think, pretty straightforward. What you see is what you get. So, for example, we can see here that very close to 2.9 million pitches are recorded as high velocity and at the same time recorded, categorized as a heater. Now, make note of the fact that a heavy preponderance of pitches are on the diagonal here, which is what we would expect. But there are counterexamples to this. So look here, over 850,000 pitches had low velocity and yet are classified as heaters. Seems a little unusual. In any case, for each row, we can sum up the frequencies here to obtain our row totals, and likewise for each column, we can sum up the frequencies to obtain our column totals. The lower right cell here contains the grand total number of cases. Now, the row and column totals here should look familiar, as these are what we just looked at here with our respective univariate distributions, the two bar charts we looked at. These totals, by the way, are often called marginals because, well, they're present in the margins of the table. Now, there's a few variations of a two-way table that we can calculate here. One popular variation is called a cell proportion contingency table. To obtain cell proportions, we divide every entry in our table by the grand total. Now, one thing worth pointing out is that while these proportions are pretty easy to read, this distribution as it stands is not fully informative. And what we mean by this is that if someone wanted to know, for example, how many pitches were high velocity and off speed, the answer is not available. So for this reason, when we show proportions in this way, cell proportions, we should include the total number of observations. Now, our summarizing data mantra is comparison, and comparison is absolutely of the essence when looking at bivariate distributions. The side-by-side frequency bar chart, like we're showing here, is pretty effective. In this example, we've split the x-axis here on the bottom based on low velocity or high velocity, and within each of these categories now, you can see we've split our new pitch type off speed or heater category. By using color or texture, some people just use texture, we can highlight, for example, that heater pitch types are much more prevalent among high velocity pitches and low velocity pitches. It's exactly what we would expect. We can also stack the bars like so and obtain a so-called segmented or stacked frequency bar chart. And this is also a very popular way to show the distribution of two categorical attributes. Okay, before we close out, now it's time for our QuantSlob Horror Challenge. It's a two-parter. Using our imagination, how might we use pie charts to show a bivariate distribution between two categorical attributes? Second part. Our high-low velocity categorical attribute was created from a numerical attribute, pitch, start speed. So question, how might we convey the relationship between the off-speed heater categorical attribute we created and the original numerical pitch velocity attribute? That's it. That's going to do it this time around. Thank you very much for tuning in. I really do appreciate it. Don't forget to stay tuned for more QuantSlob.